think it's recording right now. Let me check. Yeah, it's recording. Okay, so we can start. So, what we are going to do today is our cell is done with the TMRE. And now we want to track our cell with TMRE. So first thing first, we're going to locate where the cell is. So here we are going to use the wide field imaging to locate the cell. The intensity of the wide field LED usually are set to 10 first. And then we need to open this path. So here, the light up path is telling you where the light is going through. It's going through from the top to the cell and then go to the objective and then go to the camera right now. So here I'm going to use none for the reflector because it's wide field. If you are using different light fluorescence, you need to choose the right reflector. Okay. So let me this system reset every time. So now you can see the light path is going through here to the sample, to the objective, and then to the camera. So in this case, it's going to the camera, so we can do live imaging on it. Here you see it's too bright, so do auto setting first, and then slowly adjust your focus until you can see the cells. We have a lot of HeLa cells here. So let's go look at the cell of interest. For example, this area. And now we are sure the cell is focused. We stop live imaging. And because we know that our cell is done with TMRE, we can check if the standing is well here using the laser LED. TMRE citation is 561, so we use 555 in this case. And then you can see here, the light is not passing through the cells. So that is because we are using a specific range of the laser. And so we need to choose the reflector for it. So we are using 555, which is in the red range. So we can either pick this one or this one. I'll use this one for now. And you can see the light going through the reflector, go up to the objective, to the sample, and then reflect back to the camera. So we can now do the live imaging. So you can see here pops up the color black and white. The black and white. The white is the fluorescence of the TMRE. So now we are sure the TMRE is working. So we turn off the LED, stop imaging, and then go to next step, acquisition of the image. And here I have a setup TMRE model for you guys to use. Just pick here, TMRE. And then let me introduce you guys about the setting here. So we are using the Aeroscan LSM. And this crop area is telling you what's the size of your image is going to be. And this SR is telling you we are using super resolution to do the imaging. The image size right now is 245 micrometer square. Pixel size is 19 nanometers. And for frame time is telling you if you're taking an image of this size taking one image of this size, it's going to take 7.11 seconds. And our channel, right now we have TMRE setting here. The laser we use is 561. Laser intensity set to 1%. Master gain, this is just for the image showing up performance. So this master gain can be used ranging from 700 to 900. Right now we'll just keep as default. And then everything is set up, we just do a live imaging. And you can see this is our cells stand with TMRE. TMRE is a voltage dye tracking the mitochondria, so we can refocus it. You can see when you are doing this, you'll notice that at this area, it is telling you that your laser intensity is over the maxima is over the range. So if you do a range indicator, you'll see a lot of red dot. That is telling you that honestly is too bright for them to do the calculations. So we want to avoid that. In that case, we can either lower the master gain or lower the intensity to achieve it. Right now, the master gain is 700, so I don't expect to make it lower. So I'm going to change my laser intensity to 0.5. Now we can see the red dot is lower, but still have some. So I'm going to lower it down more until we won't see it. Okay. In this case, we don't see it, and we change the range indicator back. This is the better image that we should have. And you can see it's kind of dim, so readjust the range so we can see it better. But that is telling you it's not overexposed anymore. So now we have it set up ready. Live imaging can just be stopped, and then we can just take a snapshot. It's gonna take 7 seconds for one image. So just do a snapshot. And here we can set auto, and you can see it's scanning. That is it. That is it. We get our first image. Okay. And let's go back to live. This is the image we're having. If we want to look at, for example, a specific cell like this one here, we can do crop area, focusing on that cells. And we don't want if we don't want other images, we can just change the area size here until it fits to our interest region. For example, right now I set the ratio to 5. That's telling that if you do another snapshot, the image size is going to be 63 micrometer square. It's only gonna take image of this place. It is good when we are doing like long-term experiments, especially time lapse. The fluorescence will long exposed to the laser will cause fluorescence to, let's say, photo bleach, and we don't want that. So you can see right now the frame time for each image is decreasing from 7 seconds to 460 microseconds. So let's do another snapshot. This is the cell that we're looking at. But no matter which, what's the area you are cropping, you'll notice that the pixel size is all fixed to 90 nanometers. What does that mean? That means if you crop it smaller, it doesn't help to increase the resolutions. So the way to increase the resolution is by changing an objective. So now we're using 20x. We're going to change to 63x. See. Okay, now we are changed back to 63x objective. And that means we have higher resolution right now. So let's check. Go back to the 1x live imaging. Because we change the stage, so it's gonna take some time to find the cells first. If you cannot find it, just go back to locate and then do the same thing we done before. It will be easier for you to find the cells. Or you can do use your eyes if it's easier for you. And do visual. I'm done with visually. Now I change back to the camera. So this is you can see the image we have resolution is higher at this point. So since we found the cell we were looking for, we stopped using the laser LED, stop the live image, and then going back to acquisition. So here what you notice that is everything is the same. We're using the TMRE, but the image size is decreasing from 240 something to 70 something. That's because we use the higher, the better objective that can see the more detail. And you can notice that the pixel size here is down to like 50 nanometer. That means we almost like increase the resolution by 2 times. Each image is going to take 1.9 seconds to do the imaging. And we left all the other settings the same for now. So we just do a live imaging. And best fit. Oh, did you see that? Because right now it is high. Refocus. You can notice that the cell size, we can see very clear, like this whole range is one cell. That is how we can see more detail into the cells. So let's say if I'm taking a picture of this one, here is the nucleus, here is one very clear cells. We do an image on it. We're done with the imaging. And now if we are looking, so if I just like move in, you can see we can even see the crystal structure over here already. So let's say if I'm only interested in crystal structure, I can do a crop here. Maybe the size I'm interested in here, 5. And then do another snapshot. See? You can see the crystal structure here already. That is how we do the error scan. Okay. So that is basically that's the basic of this how to use error scan. So more advanced method, I'm probably gonna record another movie for that. But that is how you do error scan. Okay. And also like right now, since we're done with the experiment, all the image we have here, we want to save them. But before saving them, you need to do here at this tab here, error scan. You need to process this is the raw file we have. It's going to be .cdi, but we need to do like super resolution process first. So we will use the default auto filter. It will calculate the best for you. So you just need to create process images. And then it will create a processed one for you. Otherwise, if you are using other software like ImageJ to do image processing, if you use the raw file, it won't get you will have like a couple layers. That's because how the error disk is working is you will have a very hard time. You need to do error process first. So what we're going to do is we're going to error process everything. And save them all together. Okay. Okay. We have right now we have every process 4 images and 4 raw images. So what we're going to do is save select as, and this is a tutorial for today. So I'll give it the name tutorial. Release and tutorial. Okay. And I'll name it as it will be like descending. So we will start from the very beginning. So what I'm going to do is I'll save it as 0, 9, 1, 5, 2, 3. Let's start from 3, 0, 1. This is the 20x image. And this is how we save in BirdLab, just using the name styling. And 3, this is 63x objective. And oh, here you can notice that all the file that's every process will have a new name at the bottom, every process. So right now I'm going to just use 23301. This is the name of that 20 objective. I'll use the same name here, but we'll keep the every process at the bottom. Okay, so that's it. That's all for using the error scan, and we'll see you next time.